this is our first shot at this flipped classroom and notes via YouTube or DVD if necessary. So what we're going to start out with is simple binary compounds. Basically, the way we would refer to them as classes, we're gonna make sure we know how to name the gold and blues, and we're gonna make sure we know how to name the orange and blues. Okay, gold and blues would be referred to technically as type 1 ionic compounds. Those would include any metal from column 1, column 2, or aluminum, and a variety of nonmetals. Some examples would include, we have sodium cation, which would be written this way when we show it all by itself. Okay, and we put it in a compound with chloride anion, which would be written that way when it's all by itself. When you combine those two together, we end up with NaCl. And the process for naming that, and to remind us, we can underline sodium's a gold, okay, and chloride fits in the blue category. We can trust those are blue and gold, so we can trust those. So all we have to do is name the metal, and then the nonmetal, you take its name and you cut off the end and add the suffix IDE. So you have sodium chloride. Now it doesn't matter if we change the nonmetal ion. Say we want sodium with oxide. It doesn't matter how many of either of these ions we have in the compound, they are named the same way. We all know that compounds have to have an overall charge of 0, they must be neutral. So we must take the sodium plus 1 ion, and in order to make a balanced compound with this oxide ion with a charge of -2, we have to have 2 sodiums. That still doesn't change its name, because it's still gold and blue. So this is sodium oxide. Okay. Now, when we start using metals from column 2, we know that they have 2 outermost valence electrons. It's easier to get rid of those 2 than try and go get 6 to have a full valence shell. So we know that anyone in column 2, whether it's beryllium, magnesium, calcium, strontium, barium, radium, they all form ions that are +2. So now if you take calcium and make a compound with chloride, you have to have a charge of +2 here, with -1 here. So the way they go together is CaCl2, still gold and blue. Calcium chloride. You could also take calcium, partner it with somebody like phosphide or nitride or arsenide. Okay. Calcium has a charge of +2. Phosphide has a charge of -3. Now I can't turn 2 into 3 or 3 into 2, so to balance these out, we find the least common multiple, which is 6. Okay, 2 times 3 is 6. 3 times 2 is 6. Now these are balanced. Okay. And a helpful hint for compounds like this, when you have an even charge and an odd charge, basically what you do is you flip them and they become the subscript for the other element. Okay? So it didn't matter whether we had 1 for 1 like calcium oxide, doesn't matter if we have 1 with 2 calcium chloride or 3 with 2, they all get named the same way, and all that is name the metal, and IDE. So you take phosphorus and make it phos 5. Okay? So these are all named the same way because they are gold and blue. Okay, gold and blue. Now, this whole gold and blue thing does not make sense if you don't go through the process of color coding your periodic table like we did the first day. Okay, so one last time, our naming rules. When we see gold, a gold metal with a blue nonmetal, we trust that, we know their charges, so all we have to do for the naming rules is name. You take the name and IDE it. Okay? Now the next category of ionic compound we want to talk about are oranges. Okay? They include oranges. Now if we have orange and we have blue, okay, we have to add an element to, or add a characteristic to the name. Okay. The reason we trusted the golds and the blues was because golds, column 1, always form an ion with a charge of +1. Column 2 always forms a cation with a charge of +2. Aluminum always forms a cation with a charge of +3. We also know that the nonmetals, that the halogens are going to be -1. The oxygen and the elements in its compound are going to be -2. Nitrogen, phosphorus, arsenic are going to be -3. Okay? So we still know what the blue anions, what their charge is going to be. What we don't know is what these oranges are going to be. Okay? The oranges come from the transition or heavy metals. Okay? Transition metals are in this span. Later we'll refer to those as the d orbitals. Okay, but you have your flat range of 10 by 4 right here in your periodic table. Those are the transition metals. The guys under the stairs here, those are the heavy metals. When we're using our vocabulary, these are referred to as multi-valence ions. And for what we're doing, basically there's a very complex electron structure, and if you add energy to the system, you can have a different ion. Okay, so what that means for us is that iron has the ability to form an ion with a charge of +2 or a charge of +3. Now those are the most common. The truth is there's more than that, okay, for many of these elements, okay, but we'll be concerned with their most common. Okay? So the reason we're dealing with this is if I'm talking about iron oxide, I have to be able to identify whether it's iron with a charge of +2 or iron with a charge of +3, because those will be different looking compounds. If iron has a charge of 2, it combines with oxide 1 for 1, because oxide has a charge of -2. If we have iron with a charge of 3, that compound balances differently. Okay? And what you need is 2 irons and 3 oxides. Okay? So iron oxide can't be the name for this thing and the name for this thing. So we have to find out a way to isolate those from one another. Now, once upon a time, and even on some chemical labels, you'll still see that what they would do is take the old name and us equaled lower charge and ick equaled the higher charge. Okay? The good news is we don't really use that anymore. Okay? What we do is we simply use a Roman numeral to identify its charge. Okay, remember we'll use this over and over again. We'll say the Roman numeral stands for its charge. Okay? The Roman numeral does not stand for how many of them are there. It stands for its charge. Okay? Therefore, erase some of this. Okay? We already said this is iron with a charge of 2, and we already said this is iron with a charge of 3. So it's real simple. Iron 2 oxide, because that's iron with a charge of 2. Okay, and this would be iron 3 oxide. Okay, so we need to use what we know about the charges of the nonmetals when we start with a formula instead of starting with a name. Okay, so let's say we have this compound and we have this compound. We need to name both of them. Okay, so I know this is lead, I know this is oxide. I identify them. These are oranges. So their position on the periodic table doesn't tell me their charge. Their column doesn't tell me their charge. I have to figure it out using the nonmetal. So I know that oxide has a charge of -2. So for this to cancel out and have an overall charge of 0, I know lead must be 2. So this thing's name is lead 2 oxide. Okay? We're using lead again. Now I look at chloride. Chloride has a charge of -1. There are 4 chlorides to cancel out this lead. So I look at -1 times 4 means my overall negative charge is 4. Must be canceled out by +4. There's 1 lead to have all that charge, so that is lead 4 oxide. Okay? So when it gets down to it at the end, the difference between naming golds and blues and orange and blues is simply using Roman numerals. You still name IDE. Okay? The big deal is, though, remember, Roman numeral is the charge.